Hello and welcome to Textbook Engineering Problem. Today we're working out of Elementary Principles of Chemical Processes 3rd edition. At 25 degrees Celsius, an aqueous solution containing 35 weight percent H2SO4 has a specific gravity of 1.2563. A quantity of the 35% solution is needed that contains 195.5 kilograms of H2SO4. That's sulfuric acid. Okay, A, calculate the required volume in liters of the solution using the specific gravity. Okay, so we want to know how much volume we're going to need. And we know that the specific gravity is equal to 1.2563. Okay. We also know that the final mass is equal to, or the mass of the sulfuric acid is equal to 195.5 kilograms. So we know that the total mass times the mass fraction of sulfuric acid equals the mass of sulfuric acid. I'm assuming that the rest of it is, it's an aqueous solution, so the rest is water. So we know that the mass of water plus the mass of the sulfuric acid equals the total mass as well. And that the mass fraction of the water plus the mass fraction of the sulfuric acid is equal to 1. Therefore, we know that the mass fraction of the water is 0.65, and we know that the mass fraction of the sulfuric acid is 35. Okay, so from all of this information, I think we can calculate what the total mass is because we know what the mass fraction is and we know what the mass of sulfuric acid is. So the total mass equals the mass of sulfuric acid divided by, and this equals 558.57, and the mass of the water we can now calculate, and that equals 363.1. Okay, so now the volume is equal to the mass over the density. $444.6 liters. Great. In part B, estimate the percentage error that would have resulted if pure component specific gravities of H2SO4 and water had been used for the calculation instead of the given specific gravity of the mixture. Okay, so now we assume that the volume of the sulfuric acid plus the volume of the water is equal to the total volume of the solution. Otherwise stated that the volume is conserved. All right, so equals the mass of the sulfuric acid divided by the density of the sulfuric acid that they gave to us, and the density they gave to us was 1.8255. Okay, And so now we're going to calculate this volume. This equals, and this equals and the volume of the water the mass of the water is 363.1. Okay, so that is the volume of the water. And now if the volume is conserved, then the volume is equal to 470.2 liters. So it told us to calculate what the percentage error is. So percentage error is equal to the value, this B, minus the true value divided by the true value times 100%. Okay? And so that means the error is 470.2 minus 444.6 divided by 444.6 times 100%, and that equals 5.75%. Okay, so what that means is that the value that we got for the volume, assuming that volume is conserved, is actually about 5%, now closer to 6% higher than what the actual volume is if you calculate what the volume is based off of the known density of the solution. Okay, so that's a good illustration to show that volume is not a conserved quantity. Even with incompressible fluids, when you mix them together, the volume of the mixture is not necessarily the same as the volume of the components. Okay, great. So thanks for joining me on this problem. If you have any comments or concerns, put them into the comments and I will respond to those with correction or some insight to help you out. And if you have any questions that you'd like me to look at specifically from this book or from another engineering book that I'm familiar with, I'll be happy to take a look at that and make a video about it. So any requests you can put into the comments. Otherwise, thanks for joining me on this video, and I hope to see you in the next video. Thanks.